Hello students, welcome to the class on power transmission. So in the previous class we discussed about the belt drives. So in this video we are going to discuss about the gear drives. So the meaning of gear drives, so where we are going to transmit the power with the help of gears. So when we are going to use the gears, when we have to transfer the power from one shaft to the another shaft, which is very nearer. So then we are going to use the gear drives. So what are gears? So gears are called toothed wheels. Right. Say for example, so these are the two gears which have. So these are the toothed wheels. This is a wheel, circular wheel. On this wheel, on the circumference of the wheel, we have a teeth. So this we are going to call as gears. So when these gears mesh together, so when the driver gear is going to rotate, another driven gear is also going to rotate. So this is what we are going to say, the transmission of power from one shaft to the another shaft with the help of gears. Okay. So in there are different types of gears are available. Okay. So there are different types of gears. In one among this is the spur gear. See, so here we are going to transmit the power from one shaft to the another shaft. On each shaft you are going to mount a gears. These are the gears I have shown. So in the spur gear, so when we are going to use the gear, spur gear, so when we have to transfer the power between the two parallel shafts. This is one shaft and this is another shaft. These are parallel to each other. So then we are going to use the spur gear. Not only that one, so it should be non-intersecting type. So whenever we are going to extend this shaft, it is not going to intersect. That's why the spur gears are used when we have to transfer the power between two parallel shaft and non-intersecting type. So that is the use of spur gears. So next one is the bevel gear. Okay. So this is another one shaft. This is another shaft. I need to transfer the power from one shaft to another shaft. What is the alignment of the shaft? The shafts are at 90 degree with each other, right? So the shaft is 90 degree with each other and they are intersecting type. They are intersecting type. So then we are going to use the bevel gears. Okay, so that is the application of it. So next one is the helical gears. See, this is similar, somewhat similar to the spur gear. So when we are going to do the spur gears, when the two shafts are parallel with each other and non-intersecting type. So when we are going to use helical gears, when two shafts are parallel or non-parallel, if it is inclined at certain angle. Okay, and it should be non-intersecting type. Okay, this is one shaft and this is another shaft. This may be parallel or it may be at a certain angle like this. So then we are going to use the helical gears. So next one is the worm gear. So this is the upper wheel that what you are going to see, that is called as the worm wheel. So that is also having a teeth on it, and there is another unit is there that is called as worm screw. So where I need to transfer the power from one shaft to the another shaft. Okay. So here mainly see the one shaft is like this and the another shaft is like this. That means the two shafts are perpendicular to each other, but it is non-intersecting type. Okay. So whereas when we come to the bevel gauge, so these two shafts are perpendicular to each other, but it is a intersecting type. So that is the major difference between the worm gear and the bevel gear. So next one is the rack and pinion gear. So this is a gear that what you are going to see is a pinion and the rack, a long linear type of structure that we are going to call as rack. So when we are going to use this, so when I need to transfer the rotary motion to the linear motion. Okay. So when this is going to rotate in the clockwise direction, so this is going to move in this direction. That is the linear motion. So when I need to convert the rotary motion to the linear motion, so then I am going to use the rack and pinion gear. So these are the various types of gears so that we are going to use. Okay, I hope you understood. So then let us go to the next topic, that is on the gear trains. Okay. Okay, the next topic in this is gear train. What is the meaning of gear train? When two or more gears are used to transmit the power from one shaft to another shaft, that arrangement is called as what? Gear trains. Okay. So now there are different types of arrangements of gear that we can do. So based on that we have a classification. The first classification is simple gear train. The second one is compound gear train. The third one is reverted gear train, and the fourth one is epicyclic gear train. For our syllabus, we are going to discuss about the simple gear train and compound gear train. So let us see the arrangement. So simple gear train. So this is one shaft and this is the another gear. And these two gears are mounted on a different shaft. So this is a let us say driving shaft, driving shaft, driving shaft, and this one is driven shaft. Okay, and the driving gear, I am going to say this one as A and this one as gear B. See, only one gear is mounted on one shaft. That is on driving gear, driving shaft and driven shaft. Okay, so this arrangement is called as what? Simple gear train. So now let us see the compound gear train. Then we can appreciate the difference. Okay, so here gear A is meshing with gear B. That means I am transferring the power from gear A to gear B. So now the next one is the compound gear train. So we have gear 1 which is mounted on one of the shaft, and we have another shaft. This is gear A, this is gear B, and we have another shaft. This is gear C, and another one is gear B. See how many gears are there? There are 4 gears are there. That is A, B, C and D. So here my main intention is to transmit the power from gear A to gear B. Okay. So in between there are, so totally I am using 4 gears to transmit. So here gear A is meshing with gear B and gear C is meshing with gear D. But gear B and gear C are mounted on the same shaft. So that's why this arrangement is called as what? Compound gear train. When two or more gears are mounted on the same shaft. So then that arrangement we are going to say that one as the compound gear train. So whereas in simple gear train, so only one gear will be there on the one shaft. So that is what we are going to call as simple gear train. And we should know the velocity ratio, how to calculate the velocity ratio of a gear train. So gear train means, so we are going to use more than 2 gears to transmit the power. So then only we are going to call as what? Gear trains. So we should know the velocity ratio of a simple gear train. So when 2 gears are meshing with each other, what is the velocity ratio? So it will be equal to N2 by N1 is equal to d1 by d2, that is equal to p1 by 2. So what is the meaning of n2? So speed of the driven gear. N1 represents the speed of the driving gear. D1 and D2 represents the pitch circle diameter of driving and driven gear. T1 and T2 represents the number of peaks on the driving gear and number of peaks on the driven gear. So this is a very important formula, that is the velocity ratio of gears. So using this, so we are going to find out the velocity ratio of simple gear train and compound gear train in the next video. Okay, I hope you understood. Thank you.